Hi, I'm Tom from Migot Photography. Before we dive into this topic about fine art printing, there's just one thing I'd like to share with you. You may be familiar with the Tom Migot Photography page on Facebook. It's been there since 2012, and I've been posting a lot of things on there, absolutely everything, even in both languages, which I admit is quite confusing if you don't understand French. Well, I've actually made the decision to make it English. Only English now, and it's going to be dedicated to my wedding and portraiture business. So for everything related to tutorial, courses, workshops, and my work, well, you can find it here, Tom Migot Photography Academy. So if you like what I do, if you want to follow my activities and get any news about the workshops that I do here in Scotland and across Europe, well, this is the place to be, and you know what to do. Show your appreciation with a simple like. Now let's go in the tutorial, shall we? Topic of today, well, it's color management, and I'm going to be frank with you. I usually spend a lot of time preparing my episodes, writing the blog and so on, but this one has taken me a huge amount of time because I really wanted to do it right. There's so much content, so much things to say, and I've seen what's been done online, whether it's on YouTube or on blogs and so on, and I always found things that were either lacking details or too much details or very confusing even for somebody who knows very well the subject like myself. So I really wanted to do something simple and not confusing for you guys, and I hope that I've achieved that. And so in order to do this, I've done two different things. I've actually created a PowerPoint presentation that I'm actually going to use, because that way I can actually see on the screen as I'm explaining it to you. It helps me following a thread and not get lost or missing some details. But I've also written a very big blog article with a lot more detail. There's always more detail in my blog article than there is in my videos, but on this one, trust me, there's a huge amount of content in the blog article. So I invite you to actually go check the blog article after this video, and if you don't know where it is, well, the link is in the description, but you have a link popping up right here on the top, so I invite you to go there. So the topic of today, color management. If you remember the previous episode, which was the introduction to fine art printing, I've mentioned 4 ingredients to obtain great photography print. And one of them was having an optimal color management. Color management is basically a mean to ensure that all your devices are talking to each other and understand each other, so you can reproduce your work accurately and constantly, and being predictable as well. So to talk about color management, we have to go to its foundation, and at the core of color management is color spaces. And to explain what a color space is, I want to explain you what a color model is. A color model is basically a system, a formula to represent colors. And here I've listed 5 of them, and you may know some. RGB, standing for red, green and blue. I'm sure you heard of that. CMYK, cyan, magenta, or cyan, yellow and magenta and black. The next one that looks like a cross, that's the lab color model, and we'll talk about that afterwards. And we have the 2 others, HSL and HSV. The HSL one, as a matter of fact, if you use Lightroom or Photoshop, you may have seen some tools that actually are mentioned as HSL. Well, we have 5 color models here, but we're going to focus on the first 3 the RGB, the CMYK, and the lab color model. One thing that you may notice already when you look at those 3, especially the 2 first one, is that the RGB and the CMYK models, they both use 3 primary colors, and from those 3 primary colors, by mixing them, they will create a color. The lab is a different type of model. It's actually using 3 axes. It's a vertical axis for luminosity, and 2 other axes which are hue variation, going from green to red and blue to yellow. and the lab color model represents all the colors visible to the human eye. So let's dive into the first color model, which is the RGB. The RGB color model represents colors as emitted directly from the light. As you know, there is no such thing as white light. Each light has a color. As a matter of fact, look at the rainbow. It's the full color spectrum. But the interesting thing is when you actually mix those colors, you can obtain white. If you mix the three, green, red, and blue, you will obtain white. This color model, because it represents color emitted from the light, it's a good model to use for cameras, scanners, and displays. We call this model an additive color model, and it's because you create colors by mixing colors. And when you start, you have nothing. You have black, because it's the absence of light, and then you start adding some light, so you add, and that's the reason why we call it additive color model. The interesting thing is when we look at those three primary colors, the red, green, and blue, they have values, and those values can go from 0 to 255. So if we look at three different colors, for example, black, to obtain black, as I said, it's the absence of light. So it's not surprising that the value for the red, green, and blue is 0. But when you want to obtain green, well, green is easy. It's already a primary color. So it means that you don't need red, so red would be at 0. You don't need blue, it would be at 0, but you will need green at 255. It's good to note, though, that I put 255 for green, but basically you could have any value within the green, so from 1 to 255, and that would still be green. It would just be a different variation of green, but it would be green. White, well, as I said earlier, white, you would obtain white by having 255 of red, 255 of green, and 255 of blue. That's how you obtain white. The next color model is the CMYK color model. And unlike the RGB one, the CMYK color model represents colors as reflected from a colored surface. So it all starts with the white surface, a white medium, like a paper. So the paper is white and the light bounces off it and reflects its brightness. But then you add some color onto this medium and it gets darker and darker. And this is the reason why we use this color model for printing, because it really represents that color reflected from the medium surface. We call this color model a subtracted color model because the more color you add to it, the darker your medium becomes, and the light is less reflective, it's less bright. Interestingly, when we look at the values that each of those three primary colors can get, it varies from 0 to 100%. So it's not expressed in just numbers like for the RBG, it's actually using percentage. And when we look at the color white, well, as I said, white, that's the color, the native color of your medium. So there's no color added onto it. So it's normal that it's 0% of cyan, 0% of magenta, 0% of yellow, and 0% of black. Whereas green, for example, green is not one of those primary colors, and you will need 63% of cyan, 0% of magenta, but 100% of yellow and 0% of black. On the blog, by the way, there is a chapter on magenta, where I explain you why magenta is actually not a real color. So if you want to know why, well, just read the blog. The next thing to talk about is the black, CMYK. Here we see only three colors, the cyan, the magenta, and the yellow, but we added a fourth color, which is black. The reason is, as you see, if you mix those three primary colors, you obtain black, but it's not real black, it's more like a muddy dark brown. And so if you really wanted to have a true dark black, then you would need to have this fourth color. But there are also another reason for it. The first one would be financial, because if you wanted to obtain black using only those three primary colors, you would actually need 100% of cyan, 100% of magenta, and 100% of yellow. And that means 300% of paint just to have one color. That makes it extremely expensive, 3 times more than any other colors. Whereas if you still want to have the black that way, think of it as 300% of paint means longer time to dry it. And finally, the last reason would be that if you have 300% of paint, well, you're going to need to have a perfect alignment, and that has something to do with printing press. You have a picture here of a printing press, which is a totally different type of printer than a regular inkjet printer. You see, each vertical unit that you see here on this printer is basically handling one color. And as your medium goes across each of these units, you will get a layer of magenta, a yellow of cyan, and a layer of yellow, and finally a layer of black. Well, if you wanted to obtain black just with those 3 colors, you would need to make sure that the paper would be perfectly aligned as it goes across all these units. And that is quite tricky to do in the real world. So in order to obtain black, well, we just added a 4th color. If you want to know why we say CMYK and not CMYB, using B for black and not K for black, well, if you want to know the truth behind it, same, it's in the blog article. The next color model we're going to talk about is the lab color model. As I said, it's a 3-axis color model, and that color model represents all the color visible to the human eye. And so the first axis would be the vertical one, it's luminosity, and it goes from 0, which is the darkest point, to 100, which is the brightest one. And then we have the A-axis going from minus A, which would be the green, to plus A, which would be the red, where 0 is the neutral gray. The axis B works in a similar fashion, but it goes from blue in the minus to yellow in the positive, and in the middle, 0 is neutral gray. The interesting thing about this lab color model, beside the fact that you represent all the color visible to the human eye, is that it's totally independent of the nature of creation or the device that these colors are displayed on. Remember, the RGB was for the colors emitted from a direct light. The CMYK was representing colors as reflected from the medium. Well, this lab color model covers it all. You can use it for anything whatsoever. And that makes it a perfect translator to colors across devices and media. And that's going to be very important in our color management. Next, I want to talk to you about color space. We talked about color model being a formula to represent color. A color space is basically a range of tones available according to a color model. So, and the range of color is called a gamut. We have 3 color spaces using the RGB model and 1 color space using the CMYK. So if we look at the street diagram on the left with all the colors, basically the whole part that you see in colors, that is basically a lab representation of all the colors that there are out there. And the triangle that you have in it represents the color space that is mentioned underneath the diagram. So if we start on the left, we have the Profoto RGB, that triangle. Interestingly, this is the biggest gamut, the biggest color space that we have. And you notice that it's doing a good job at almost covering all the colors visible to the human eye. Interestingly, it goes even beyond. In theory, it actually it can represent colors that we cannot even see. What would be the point? Well, we cannot see them today. We might be able to see them one day. But anyway, it covers most of the lab color space, so it's a good one to have. The next one would be the color RGB, and you can see it's slightly smaller. It is contained within the lab. It has a decent size, and that's the most popular one. Then finally, we have the sRGB, and you can see it's even smaller than the Adobe RGB. It's older by 1 year. There is some use for it. For example, all the colors that you have on websites, well, they are sRGBs. So these are for the RGB color spaces. Then I actually put a graphic representing a generic CMYK color space, and in order to give you a better idea, better understanding as to what it represents compared to the RGB color spaces, what you see in white is basically a representation of the Profoto RGB. It's a different way of representing it. And then you have the CMYK representation inside. And that tells you how small the CMYK color model, color space is compared to the Profoto RGB. So that's one of the reasons when you're going to print something, you're not going to be able to render all the colors that you see on your screen. But we'll talk more about this. The interesting thing is, when we look at those three RGB color spaces, we said that those would actually be used by cameras, scanners, and displays. And you would think that because they're using the same color model, using RGB, so having values of those three primary colors going from 0 to 255, that if you had, let's say, a camera and you have a red captured by this camera, a color red, and the color red would be 255, 0 for the green, 0 for the blue. And then you go on to your display, and the red is also displayed as 255 and 0 and 0. You would think those two reds would be identical because they're using the same color model and the same color space. But the truth is they're not. They're using the same color space, yes. They're using the same color values, yes, 255, 0, 0. However, the rendition of the color will differ. And that is why we need to find a way to translate the colors, even when it's within the same color space. And that's where ICC Profile comes into play. ICC stands for International Color Consortium, and that was a group that was put together by 8 vendors over, now I'm not going to make much mistake, but I think it was in the 90s, beginning of the 90s. And as you can see, we have some names that are actually pretty meaningful. We've got Adobe, we've got Apple, Agfa, Kodak, Microsoft, Silicon Graphics, Suns, and Taligent. So all these were involved in some way or another, were involved with softwares, they were involved with color management, color products for printing, whether it's Adobe and Apple as well, were very involved with all this printing world as well, and still are. So the purpose of this consortium was to create an open vendor-neutral color management system, transparent across operative system, like operative system, if you don't know what that is basically your Windows or your Mac OS X, and softwares. And that is a translator, the ICC Profile. You may have seen files like this. This is an icon of a file that you would find on your computer. And basically the ICC Profile is a file that will translate color rendition across devices through your ecosystem. If you were to open the ICC Profile, well, what you would see is basically a translation of a color space to a lab color space. That's how it works. So let's look at a color management workflow and the photographer ecosystem when it comes to a photographer that would like to print. You all start from your camera, and we said that it was using RGB color model. Then we have the display, also using RGB color model. We then have a printer, and the printer will use CMYK color model. And at the center of it all, we have your computer. And the computer will use a color engine with your software, Camera Raw for Lightroom and Photoshop. As I explained, you need a way to translate, to make sure that the red of your camera is going to be the same red on your display, the same red understood by Lightroom and Photoshop, and the same red that will be understood by your printer within its own gamut, its own restriction. Well, so to do that, each of these devices of these devices will use an ICC profile. And so in the ICC profile, it's basically a table, and in one column you would have RGB values, and in the other column you would have the lab values. And each of them will be pointing to the lab, and so your color engine will use the lab and pass on the information to all the devices involved. That's basically what color management is. That brings us to the conclusion. There are details again on the blog. I've mentioned color space in Lightroom, color space in Photoshop, and color space as well for your display, and color space for your camera. So I invite you to read the blog after this video. This is a short conclusion, what we should be doing as a rule of thumb to obtain the best print possible. Well, if you are to shoot JPEG, then you need to go for the biggest color space available in your camera. You know, in the menu you can set the color space. I suggest you use the biggest one, which is the Adobe RGB. If you want to know why I specify JPEG, it's mentioned as well in the blog article. Then when it comes to display, so it's interesting. Make sure that you have a display that can render most, if not all, of the Adobe RGB color space. It will be more expensive than your standard display, but at least you'll be able to really see all the colors that your camera can capture, and make sure you get a good rendition afterwards with your print. Because if you see something that is off, you may think that actually it's the reality, when in fact it won't be once you print it. And don't forget as well about calibration. I've done a video, remember, a couple of years ago about calibrating your display. If you haven't seen this video, I invite you to click on the link that appears right now top here. Very useful. It's essential you calibrate your display if you are serious about your image. Even if you don't print, you need to calibrate. And finally, you need to make sure that you use the correct color space when editing your work. In Lightroom, you're not going to have this problem, but in Photoshop and in Design, for example, those tools, you need to set your color space for your working environment, and so you need to make sure that you have the correct one, otherwise the color is going to be totally off. And finally, the last one will be the ICC profile for your printer, and we will talk about it when we talk about paper in the future. But basically, the ICC profile considers the printer, the ink, and the paper. It's the combination of the three. And you will need as well to soft-proof your work before sending it to the printer, but that will be another episode especially about soft-proofing. So, as I said, once again, a lot of information on my blog. I hope you found this insightful, that it's not confusing, that it's clear. Next time we'll talk about printers, how to choose the printer that is right for you. Until then, this is Migot saying, if you like it, well, capture it. Cheers.